what you do is you have the original view stuff file, right? It has been declassified. So what you do is you go to last split. Okay. So what I'm going to do is I'm just going to take the same view stuff file. Okay, and I'm going to name it as a DTM, digital terrain model. Okay, dot, what would be the extension?
Hello. Anybody can tell the timing of next lecture? Hello.
Good afternoon, Professor. Sir, your mic is on mute.
Good afternoon, sir. Roshan here. Your mic is on mute, I think, sir. आपका आवाज नहीं आ रहा था. No, sir. We cannot hear you.
We are not able to hear. No, sir, we are not able to hear you so far.
So please check your mic settings. System mic कर दीजिए. So if you can remove the earphones and then check whether the system mic is working.
Can you hear me now?
Yeah, we can hear
Yeah,
you.
now we can hear you, sir.
Okay. Just 1 minute.
That's very loud and clear.
It's clear now?
Yeah, it's clear.
Then I'll not use the system.
To see you, sir.
Can I share the screen?
Yes, sir.
Can you enable the screen
One
sharing,
minute,
please?
1 minute, 1 minute. Yeah, you can try now, sir.
Okay. Can you see the screen?
Yes, sir.
Yes, sir. We can see.
Is it okay now?
Yeah. We'll wait another 2 minutes, sir. People will join, then we'll start.
Okay, fine.
Okay. Very good afternoon, everyone. First of all, sorry, sir, because I didn't realize that you are in US. I thought since it is mentioned as IIT Tripura, I thought you are in India. So I scheduled the meeting. Otherwise, I might have postponed the meeting in the late evening, like the way yesterday we did. Anyhow, so we'll start the session. Like I'll introduce the speaker. Here with us, Dr. Lieutenant General Dr. Anil Kapoor is with us. He is AVSM and VSM Supernature as Director General Electronics and Mechanical Engineering on 31 December 2020. So he is the alumni of National Defence Academy, Pune, Indian Military Academy, Dehradun, and Defence Services College, Wellington, Army War College, and National Defence College, etc. He received gold medalist during his BTech where he did BTech in electronics and Master of Engineering in Mechanical and MSc in Defense Studies, MPhil in Strategic Management. Also, he guided. He is an expert in radar. Yeah, he is an expert in radars, guided missiles, MRO asset management, and condition-based monitoring of asset. He received his PhD on his thesis on industrial base, a key determinant capability building capacity development of India. Last four decades, he did a long journey in the military services, especially on the maturation of his military leadership, and that his experience, everything helped for the military front end. And he also been Director General of Information System and 2 UN peacekeeping assignments, like Senior Logistic Officer in Angola and Deputy Chief Integrated Support Services in Sudan, etc. And he has received many honors and awards, etc. So without further delay, I just request Professor. Currently he is a professor of practice at IIT Tirupati also, because of his eminence and his research related things. We have invited him as a professor of practice in the IIT Tirupati also. So without further delay, I hand over the session to Dr. Anil Kapoor. Yeah, please, sir.
Thank you very much, Professor. It's a pleasure always speaking on seminars, and I think geospatial technologies perhaps is one of the most important technologies over the last day and a half. We've seen the various applications that hover around geospatial technologies. I'm Anil Kapoor. He's already introduced me. Thank you very much for the introduction. I will go over the subject by covering the agenda. Firstly, I'll talk about the technology stack, the opportunities which exist in geospatial applications. Since IIT Tirupati is the technology innovation hub for precision and positioning, I think there are a lot of opportunities which need to be harnessed. I'll touch upon 3 case studies on defense, where a huge amount of geospatial technologies enabled programs are underway. We shall talk of a case study for condition-based monitoring, which is a niche area, and a lot of, should I say, capabilities can be built around this technology. And then, of course, industrial automation to industrial autonomy, IA to IA, another very emerging field in the geospatial applications. I'll also touch upon some challenges which exist in implementation when we look at the real world, because while it is a very fancy word to say geospatial applications, when it actually comes to implementation, there are huge amount of challenges. Something that I faced myself when I was the DG Information Systems. And then we shall talk on few things that we could do in the TIH, along with our students, professorial staff, on way forward. Firstly, let me start by saying that technology and the world order around technology is based on 4 pillars: data, digitization, digitalization, and disruption. And while normally it is said data is the new oil, actually technology is the new oil. This is where all the difference is happening. And when we look at data, digitization, and digitalization, it has resulted in something that we call the digital transformation. And this digital transformation, assisted by a host of technologies, is resulting into a large number of disruptions. And perhaps in the 21st century, the biggest disruptor has been the geospatial technology. It's a layer which is actually making all the difference. In fact, geospatial technology is correctly called the science of where, and it is the cutting edge technology today. Looking at geospatial technology as a stack, it comprises of three pillars. First, the ICT, information communication technology, and therefore today you've got artificial intelligence embedded in a big way. And when we look at 5G, that is yet another area. We look at the kind of hardware in terms of clouds, in terms of serverless systems. That is one very important area, which is a very important pillar for geospatial technologies. The second pillar is the IoT and sensors, because this is one area when you have to see the science of where, every point on ground has to be mapped for picking up information. And when we look at mobile systems and real world systems, IoT and sensors play a very big role. And of course, geospatial data is very rich data. When we look at a point on ground, it is just not the coordinates, the lat long altitude of the point. It could result in a large number of other useful application data as to where does it exist, what is the soil configuration, if we go beneath ground, what is the water table, what are the mineral characteristics, and when we move up, what is the met data, and when we move around, what all is located. Where are, as an example, we all have seen Google Maps. Where does the next petrol bunk come? What are the important points around, important places of visit around a point? All this comprises the rich amount of data. And therefore, the GIS system is actually an information system of systems. And today, we could augment this data. We could look at a virtual reality around it. And given the quantum computing and the convergence of all the technologies, today, we find that geospatial is a huge, huge enabler. We have a lot of mapping which goes on in the 3D space using satellite imagery, and imagery data therefore becomes very important. And closer to ground, at the tactical level, we have the drones which carry out a lot of surveillance to give you very, very precise, pertinent data which would be needed either to mark forest lines, coastlines, forest fire lanes, maybe roads, and every point on the road. I recall that in the recent past, I came across one application where, using drones in Germany, Berlin, they've mapped the area so well that a blind person with headphones could walk into the streets and be precisely marking every point on ground. He would exactly know where the zebra line is. He would exactly know where the various lampposts are, and every point was mapped using drones. So that is the power of convergence that is being brought by the geospatial technologies today. And all of us who look at applications around it have to look at geospatial technologies as a bouquet of various technologies. It is just not the geographical information system. It is huge amount of electronics around it. It is huge amount of ICT around it. It is huge amount of software around it, and huge amount of data science, data engineering, and data analytics thrown in. To the extent that today we as individuals are also geospatial tagged sensors. Imagine today, the moment you open an app, say a Zomato app or a Swiggy app, you would like to see every entity that is mentioned there as to what is the rating, and which each one of us, having used that service, would like to rate it, which goes to show that today all of us have become digital in our behavior. We become smart citizens, and smart stands for very specific, measurable, achievable or attributable, realistic, and time-bound in our functioning. And therefore, it's very important for all of us to realize that we are very much part of a GIS ecosystem. And today we call it crowdsourcing. Therefore, when we look at the Earth today from a GIS tech lens, it is perhaps the cutting edge technology which is making every possible application that we think of imperative, with GIS as one of the major layers. No wonder, therefore, today, when we look at GIS, it is the key business objective in the digital world. Whether we look at supply chain visibility and optimization, it is changing the business environment. The whole business environment is changing. That is the kind of disruption. The way business used to happen doesn't happen any longer. You look at the Amazon, you look at the Flipkart, the way business is happening, door to door. It is changed because of the GIS being one of the major enablers, or geospatial technologies being one of the major enablers. The way each one of us is enabled today is very different. If you have to go from place A to place B, there are a large number of apps available on your mobile. And today, in fact, the mobile in our hands is a game changer. When you're moving on the road, you are positionally aware of every activity, every event that is happening around that place. I recall recently I was driving from Las Vegas to Grand Canyon, and on the way, there were flashes that there's been an accident at a particular place and there's going to be a delay in movement. It was also flashing where the policeman is standing and you beware because you mark your speed. So therefore, the way each one of us is today being enabled by GIS, enabled by geospatial, there's a huge, huge change. When we look at a business objective of profitability, today you have total CapEx and OpEx optimization happening. And when we look at the case study of industrial automation to industrial autonomy, we'll see how optimization is the key behind IA to IA. More importantly, in the VUCA world, we've just seen when COVID-19 got into the world space, how each one of us got affected, how the business got affected, how the economy got affected. And therefore, I think with GIS being the hub, a lot of spokes can be created in a hub and spoke manner to create a business objective or a business model which works well both in automation and autonomous mode. Let's look at some of the opportunities. And when I say opportunities, I say it with the intent that when you look at geospatial technology, a person or an industry or an organization, an institution which uses geospatial data is actually a winner. And today, if you were to define who's a winner and who's not a winner, or whom we call a loser, it is around geospatial analytics. The complete business mapping in terms of Q and Q, quality and quantity, the quality of data and quantity of data. How you are analyzing is defining your business model, is defining your business outcomes. And here, it is geospatial, it is behavioral science, it is artificial intelligence, it is crowdsourcing, it's data engineering and data analytics put together. So you have data technology, you have data engineering, and you have data science, all of them interwoven to give you a business model. No wonder today that if you bought a ticket to Leh, you would find your social media totally proliferated with companies, including Amazon, who would tell you as to what are the various deals for buying some jackets, for buying winter clothing, for buying many more things that you may need, including hotel industry, Airbnbs and others. And therefore, it has made your tourism look easy. And the one who has used the geospatial data the most, the geospatial analytics the most, actually carries the day. So therefore, when we look at from a business perspective, it makes perfect sense to use this geospatial space. And for some of us, since there are students also here, who are looking at a startup, I think you should start with the knowledge of geospatial analytics. Let's look at agriculture, another very important sector. I recall in 2008, I think 8 or 9, there was a huge experiment in Hyderabad, in Andhra Pradesh, in the Kurnool district, between ICRISAT and Microsoft. And what they did was they predicted precise weather, analyzed the precise soil condition, and defined the time when seeds should be sown, defined the timings when there should be some irrigation in terms of water, irrigation in terms of other requirements of the soil, everything monitored closely through technology. And within a year, in this experiment, the yield improved by 30%. So therefore, yet another opportunity where in agriculture itself, a huge amount of difference could be made by adopting geospatial technologies. When I was in IIT Tirupati recently, I came across an IM graduate who was from a neighboring village in Tirupati, and he was there in IIT trying to work out a model so that his village could adopt technology. And during the interaction, we realized that geospatial was a good start point. And therefore, I mean, we could have a lot of convergence in the field of agriculture with technology, with precision and positioning thrown in to create, if I may say, a farmer's delight in his farms, which he's never seen before. Let's look at the services sector. The way the services sector has grown today, it is all based on GIS and software as a service. We all know the World Wide Web, when it has opened the world to us and made the world flat. Today, every conceivable service that you need, including governance, is all E enabled. And in E, GIS is the most important layer. Every function that happens, whether it is tourism, whether it is your driving license, whether it is your passport, anything and everything today in the services sector is all GIS enabled. And since we've already had a lot of discussion on these things, I'll not belabor more and get on to the next, which is smart cities. And smart cities together can lead into smart states, and smart states can lead into a smart nation. I recall having read a paper on this, in which in America, way back in 1980s, they started a program called TIGER, Topography Integrated Geographic Encoding and Referencing. And every possible point was geomapped. The geography, along with, or rather geographists, along with scientists and technologists, created a tiger database, which actually made all the difference in mapping every piece of ground. Which is the ground which is good for irrigation, which is the ground good for industry, which is the ground which is mineral rich, which is the ground which is good for residential complex, and the complete town planning and town mapping happened around this, looking at weather, looking at wind conditions, looking at soil configurations, water availabilities, water tables, and so many other things. So therefore, when we look at smart cities, since a lot of programs are running around smart cities, I think it makes perfect sense to look at the complete data which hinges around and look at how do we plan a smart city. Some amount, of course, will be legacy, but some amount which is not legacy can be analyzed and planned based on the geospatial mapping. So some of us who are looking at startups or looking at creating solutions around smart cities should study tiger data and come up with a very, very interesting model. The next is disaster management. I think this is a huge, huge area where there are huge applications. The crisis mapping is very important. Every place through the tiger data, if I may say, can be so well mapped that when crisis happens, you could actually map the satellite imagery with what it was before the crisis and after, and see what are the areas of opportunity to restore the situation. Whenever any disaster happens, perhaps the first thought is, how do we start and where do we start the restoration? I think a GIS application prepared around imagery mapping can help create a crisis map and, more importantly, a crisis support map. So therefore, this is another very interesting area which is developed and developing, because disaster is perhaps the only inevitable certainty that happens at a point in time in some places. And therefore, if we have factored this in our smart city, smart state, smart nation program and created a app around it, we would be able to manage disaster well and create, should I say, a lot of savings in terms of human lives, savings in terms of a lot of resources, and coming up with a very doable master plan for short, medium, and long-term support. So some of us could look at this as an opportunity to create an app for disaster management. When we look at manufacturing sector, the whole system today is transitioning from automation to autonomy. Now we have Industry 4.0, and today we've started talking of Industry 5.0, which has a transition from automation to autonomy. I'm sure that we all are aware about the Industrial Revolution, the latest being the Industry 4.0, which is now being further refined into Industry 5.0. When we look at the case study, some more discussion we shall do there. Coming to some defense applications, I think defense is a huge area where geospatial technologies play a key role. In peacetime, there's a huge amount of interest in gathering. There's a huge amount of interest around surveillance. There's a huge amount of interest around reconnaissance. There's a huge amount of interest both on your side of the border and the other side of the border to know what is the terrain, what is the terrain configuration, how is it being used, where are the missile silos coming, where is the warehousing happening, and why is it happening? I mean, in India, we know across the border, northern border and western border, we have which inimical borders, and therefore, in the defense, imagery interpretation, the changes that happen in the imagery is of huge interest to defense. It may appear to be a very innocuous warehouse, but it could have a military significance. And therefore, there are a lot of opportunities around defense applications. And therefore, I'll now straight away jump onto the case study for defense application. And when I say case study, it is more of highlighting a problem statement so that some of us can cash on this and maybe come up with some very meaningful applications. Let me look at the opportunity in terms of a core integrated battle zone. And you could ignore the core for the moment for all those of you who are not aware of the various units, subunits, and theaters and sectors of operations. But enough to know that in a core integrated battle zone, you could have about 30,000 troops or thereabouts, about 30,000 load vehicles or more, about 700 or tanks, 400 guns, 500 sensors or more of all types. And when I say these sensors are the major sensors, it will be in terms of radars, electro-optic sensors, drones. And therefore, this is the kind of footprint. When we look at terrain and topo, it's about 1,000 kilometers by 300 kilometers, about roughly 300,000 square kilometers area. It could be mountains, it could be high altitude areas also thrown in, it could be plains. And when we look at transportation in these areas, we look at air transportation, rail, road, and animal transport. In some cases, where we have lakes, big lakes like you all have heard Pengongso Lake, it could also be use of these speedboats. So therefore, that is another dimension of transportation there. Normally, we carry out stocking for about 30 days, which could mean about 2,000 tons of food supplies. And since each of this has a shelf life, you could look at the complexity that gets added if you were to put a geotag on timeline of every supply that is being placed at a point. We have about 15,000 kiloliters of FOL, 4,000 tons of ammunition. And this data I have put only to give you a sense of the enormity of the quantities that are involved, and therefore the importance of automating all this. And when I was DG Information Systems, it was a huge, huge challenge putting all this together, and more of it when I move to the next slide. And when we look at a daily maintenance which goes on, we could look at anything of up to about 60 to 100 tons of food supplies, 100 kiloliters of fuel, oils, and lubricants, and about 100 tons of ammunition. And this could go on and go higher depending on the intensity of battle in war. So if the intensity is high, all this can increase manifold. So that is the kind of challenge which presents in terms of a GIS or a geospatial opportunity. Now, I have put for you a map to indicate to you that when you look at, this is the area which is on the Indo-China border. And when you look at this area, please try and see the contours. We are looking at 20,000 feet, which is about super high altitude area. We're looking at lakes at these altitudes. We're looking at very few roads. We're looking at steep climbs and steep contours, which you can see. And the scraggy line here could actually be referring to the forward line of own troops, which is so important. And sometimes in mobile operations, this line is very important because when your own Air Force has to engage enemy targets, they always look at what is the forward line of own troops, and therefore the importance of real-time information management. And so this is the kind of areas in which normally you have to operate. This is the kind of areas in which you have to do develop your defenses, develop your warehouses, carry out a lot of movement with minimum load, and therefore a lot of automation can help. I mean, all of us who use Google Maps know the importance of how information can help you get to from one place to another in the fastest time. The distance may be more, but the time is of essence, and therefore, in all military operations as well, time is of essence, and therefore, a geospatial application is very important when we look at the defense. Now, I call it innovate and integrate way of geospatial opportunity. And why I say innovate and integrate is because it's a very, very dynamic situation. Now, the whole program, if I were to put it together, I would call it a real-time and space integrated tri-service C6 ISR planning platform. This is the overarching, should I say, requirement. And when we say C6 ISR, I would qualify C6 stands for command, control. Command is of resources, command is of your complete human resources that you have, the various echelons that are provided to you in a particular area of responsibility. Control is of resources. Communication is very important. So command, control, communication, computers, very important when you look at the ICT space, cyber, which is a very, very pertinent threat, and therefore you have to be cyber safe. And the 6C is combat. That is what you want to automate. ISR stands for intelligence, surveillance, and reconnaissance. And this is the planning that you have to carry out. And it involves operational planning and monitoring op readiness of various missions at various locations at various points in time. So it's a function of time and space. Monitoring of operational logistics and supply chain, which we call, we started calling it the Indian Armed Forces Information System. It is like Indian Railway IRCTC, Catering Transport Corporation. So it's one single piece solution for tourism, IRCTC. So when we look at the Indian Armed Forces Information System, it is all information thrown in, totally geotagged, whether it is operations, deployments, own, enemy, logistics, your movements that are happening. Something which is very, very regularly carried out is called advanced winter stocking. Today we are in summer months. What we are actually would be doing in the high altitude area, something called advanced winter stocking. You stock up for the winters because in the Great Himalayan range, when there is snowfall, the passes are cut off, and then you have to, for almost 5 to 6 months, you have to be dependent on what you stock. Then there is advanced monsoon stocking. We know that monsoons are going to hit us very soon, and therefore sometimes the road space gets washed off because of landslide, because of heavy water, and therefore flooding, and therefore we do in these remote areas advanced monsoon stocking. Then there's ammunition dumping. So it's a huge amount of logistic activity, and therefore there has to be a great application around it. Met data is very important. All artillery, all firings are very, very dependent on met data, because all your projectiles, all your missiles go through atmosphere over long distances, and therefore real-time met data is very important. So therefore an app around met data would be very, very important, and therefore all this hinges around a decision support system. Let me share with you an example. When we had the intrusions in Kargil way back in 1999, and there was a very, very odd situation that had developed in J&K. We were looking at how do we put this situation. One of the options that was thought of, why not create a similar situation for Pakistan for them to retort? And therefore, when we brainstormed on this, we said, okay, let us start stocking for this operation in a particular area. And then the next question was, how much time will it take us to be ready here? And how much force can we muster for this? Now, all this became a huge, huge manual exercise. And the manual exercise took us almost a week to plan and another 3 weeks to execute. And therefore, the decision support system looked at, okay, let's plan on about 30 odd days, that we'll need about 30 odd days to do it. But should there have been a decision support system wherein you throw in the data, analyze it into an information and come up with an information system which helps you take a decision, things can happen much faster. So therefore, the real-time and space integrated tri-service C6 ISR planning platform is perhaps where the future lies. In real world of defense, when what we say red meets blue, red is your own force, red is your enemy and blue is your own force, we call it red and blue. And it's very important to do what is called the blue force tracking and the red force tracking. You should know where the enemy is, you should know where you are. I just spoke about forward line of own troops, which is based on blue force tracking. And therefore, satellite imagery interpretation, aerial imagery interpretation from various aircrafts, drones, and underwater imagery interpretation become very, very important. To give you an example, a swath of 8 kilometers by 8 kilometers of satellite imagery can take anything from 12 hours to 2 days to find military objects of interest. That is the kind of time. But when you did it with an AI-driven platform, it happens, an 8 kilometer by 8 kilometer swath gives you a satellite imagery interpreted in about 15 minutes. Where is 12 hours and where is 15 minutes? So that is the kind of difference technology and geospatial technology can bring about. And therefore, it is very important to look at blue force and red force tracking. You have to prevent strategic surprise and you have to prevent tactical surprise. If you found suddenly in a satellite imagery that across the border, there's a huge amount of force which is taking force accretion, which is taking place, something that we saw in the, should I say, early days of Ukraine-Russian war, that there was a lot of Russian presence seen along the borders. And therefore, that is how you prevent a strategic surprise. Then we saw a huge train of vehicles, loaded vehicles, moving on the road. And that's how you avoid tactical surprise. So therefore, these are very important indicators. Then you have the forward line of own troops. When you do an out-of-area contingency planning, that means you plan to do operations abroad. Maybe in your neighboring countries, there may be a need for it. You need to get your GIS information sorted, and you need to get your tracking information sorted to be able to do it. Very important peacetime activity is to identify the capability that is developing around your borders, beyond your borders. Where are the missile silos coming up? Where are the warehouses coming up? And therefore, that is another important imagery interpretation exercise which needs to be done. And then, of course, all this helps you to identify the intent of the enemy, posture yourself accordingly, and maneuver yourself to victory. That is very important. We've all seen it happen in the Ukraine-Russian war. Everybody thought it will be a huge, huge cakewalk for Russia. But I think use of technology and intelligent use of technology has actually helped see the intent, has helped posture, and has helped maneuver to make it very difficult for enemy to walk through you. And therefore, when we look at defense and the geospatial opportunity, I said winners and losers get defined by the use of geospatial space. And therefore, that is the importance of geospatial technologies, precision, positioning, occupy, and defense. When we look at blue force tracking, let me also take you through a very interesting scenario that I saw in one of the papers. Of course, imagine you got the blue cars and you got the white cars and how they're connecting. You could have the white could be red, and you could have the blue force tracking, where the blue forces are talking to each other and the red forces are talking to each other. In this case, of course, everybody is talking to each other. And this is another system where in a serverless mode, data is being transferred to talk to each other and talk to an infrastructure somewhere to give the information. And this gets me to the next case study on condition-based monitoring. Now, here are shown 6 cars or 7 cars which are talking to each other, and actually they are sensors embedded in the car who are talking to similar sensors and then getting the information through to a master or an infrastructure, which is actually monitoring the condition of each of these and is initiating some radio signals to the drivers to take some corrective measures. So when we look at a scenario like this, which is facilitated by GIS, every position is geo-enabled. As an example, the white car could be running low on fuel, and though the driver knows it, we could radio to him that at the next exit, please move out and get your fuel topped up because you're going to have a fuel situation. Or it could be an oil situation in the engine. Your engine could seize because of the oil having outlived its utility. Or it could be a lubrication issue. Or it could be a mechanical condition issue of some of your bearings failing or any other thing. So therefore, when we look at this scenario, I'm now coming out of blue force tracking and getting into condition-based monitoring. It could be a tank, it could be a car. And therefore, the diagram that we just saw, we could look at a vehicle to infrastructure, a vehicle to a network, a vehicle to a grid, a vehicle to a pedestrian, a vehicle to a device, and a vehicle to vehicle, the way we have seen it. All interactions going on at the same time on a GIS platform to help correct a condition. Now, what is condition-based monitoring? Let's take a look at condition-based monitoring. I have put in front of you 2 dials, and these are condition dials, a health dial of the engine or power pack of a car. Actually, these are of a tank, and therefore, if you look at the one onto your left and my left, you could see that the mechanical condition is orange, there's a warning. And in the operating condition, there's a red, there's a warning. And each of the warnings indicates an action to be taken. Then the mechanical stresses are green, 85%. The mounts are at 1%. The torsional angle problem is at 1%. The general condition is 62%. Come to the right dial. The mechanical health is 100% fine. Operating condition 78%. Now imagine if in real time you were getting these indications. Before it reached 21%, you would have taken some corrective measures. Before it reached 50%, you would have taken some corrective measures. Before it reached 62%, you would have taken some corrective measures. But more importantly, if you have these condition-based monitoring going on at all points in time, you will not do over maintenance. You need not do preventive maintenance. You need to do just-in-time maintenance, which is a huge, huge advantage of reducing your downtime, of reducing your costs. So some of us who are looking at precision and positioning technologies, this is a great opportunity of condition-based monitoring of cars. Look at this. I mean, when you today drive a car or your bike or anything, you have some dials which indicate to you that the fuel is running low, which indicates to you that your temperature is going high, and therefore you take some corrective measures based on the matrix that you read on those instrument panel dials. Imagine if the instrument panel dial was expanded to a large number of sensors, which could indicate to you those which are critical in terms of oranges and reds. Greens, of course, are greens, but oranges and red definitely should raise hackles for you to take some corrective measures. And therefore, it's very important to realize that geospatial technologies today occupy a prime place in every activity that you do. whether it is maintenance, whether it is surveillance, and condition-based monitoring is again a huge opportunity. Now, I'll just qualify this by saying that it's a condition-based monitoring is a cutting-edge technology for early detection of emerging faults in any equipment. It could be on the shop floor, it could be a car on the road, it could be a car in your garage, which is talking to you based on some analytics. And torsional vibration sensors are perhaps one of the very important sensors for all moving parts. There are many more sensors, I'm just touching upon one. And this torsion vibration sensor gives you the state of your engines, gearboxes, motors, bearings, turbines if there are any, and helps you give you a huge, should I say, indication before things go wrong. You have oil management. I mean, most of the failures of engines has been analyzed. Almost 54% failures happen because of poor oil management. So therefore, this is yet another very important indicator to help you analyze conditions. So imagine that a car which has been running day in and day out, and I'm looking at Ubers, I'm looking at load carriers, trucks, which actually keep moving day in and day out and do not have enough time even for maintenance. Such applications can help make sure that the downtimes are low, because if you do preventive maintenance, you incur high costs. If you don't do maintenance and bank on breakdown maintenance, you have huge downtimes. So condition-based monitoring helps you to optimize, and therefore it's where the future lies. And what has been seen as by statistics, only to maybe complete this case study, is that only 18% failures can be avoided by using preventive maintenance systems. So if you were to create a preventive maintenance system around any equipment, around any technology, it will only account for 18%. The balance 82% get addressed by technology solutions. And the cost saving in terms of spares and manpower is 50%. Your downtimes go up that much. The logistic becomes simplified, the reliability gets enhanced, and it's early corrective action. So therefore, I think there's a great opportunity in our TIH to work on this condition-based monitoring on a maybe a GIS platform to create a solution for the vehicle fleet, which is either any vehicle fleet. And if I were to extend the idea, all the transport manufacturers, OEMs, would be very keen to adopt this technology, which is niche as we speak today. It definitely enhances your operational efficiency. Okay, from here, we move to industrial automation to industrial autonomy transition. Now, we've had the industrial revolution 1, 2, 3, and 4. We are into the 4th industrial revolution. I'll not recount it, since most of us would know that it was from manual, we went into, should I say, mechanized mode, and from mechanized, we went into an automated mode. Given is the hierarchy, a 6-step hierarchy of transition from automation to autonomy. Now, if we were to look at some industries today, they still work on manual mode, largely the MSMEs. Some have graduated to level 1, which is the semi-automated mode, where humans and some NCs, numerically controlled machines, are integrated in creating a semi-autonomous kind of a industry. But in some cases, especially the OEMs, some OEMs have adopted the industry 4.0, where everything is only monitored through humans, but execution is through automation systems. Now let's move ahead from here to an autonomous, from automation to autonomy. Now, what does autonomy involve? Autonomy involves use of large number of sensors, which give you the present state of things, a lot of business intelligence and artificial intelligence thrown in to do deterministic and predictive analytics. And as human beings, what we do at all points in time is actually deterministic and probabilistic analytics and come up with a decision. This decision tool is now being given to the machine through a software and a hardware combined system. And there are 3 grades of autonomy as well: the semi-autonomous, the autonomous orchestration, and finally the autonomous operations, which is when you have a pair to planet combination happening. That means every activity which goes on in an industry is based on a control, a centralized control system, which actually enables each spoke to carry out a task as if a human being was carrying it out. That is total autonomy. Now I'll share with you an example of the bubble factory of Volkswagen at Dresden, Germany, where they are attempting this exercise of industrial automation to industrial autonomy. The kind of technology stack that is required for this, firstly, of course, a lot of upskilling is required of minimalistic human interface there, because you have to have subject matter experts who are actually monitoring the autonomous softwares, the autonomous systems, because at the end of the day, whether it is a robo welding going on, whether it is any other operation going on using robos or numerically controlled machines, you have to make sure that it is all monitored by a human being, and therefore upskilling is very important. Every space in the industry is geo-defined. That means the 3D, where a machine is, where an assembly line is, everything is geo-defined, very precise. And all these operations have to be very, very precise. The data is stored in a cloud on the edge, so there's a need for a cloud. There's data analytics, there's an IoT platform, huge sensor platform. Then there is control systems, DC and SCADA. Then there are smart sensors. There's a lot of communication because it's all a ICT driven activity. And today, a lot of wireless communication. And when 5G actually takes place, it's going to make IA to IA a reality. A lot of cognition, artificial intelligence, business intelligence, blockchain, AR, VR, modularization, 3D printing, robots and drones. So all this is the technology stack for industrial automation to industrial autonomy. And then, of course, I just touched upon 5G. It is where the future lies. And while we are talking of 5G, 6G is also coming up. We are also talking of 6G, which is a very much secure system beyond the 5G. So this is the technology stack. And now to the Dresden factory. If you were to look at this Dresden factory, what you would see is a glass bubble. On the far end, you see this glass cylinder, which is a tower. It's about good 100, roughly about 100 meters high, which has got large number of floors. As we move in the clockwise direction, look at the shop floor. It's all automated. You have a body, a car body moving. Now, the whole process actually is very interesting, and I would recommend you to YouTube this and see how it happens. A customer comes, customizes his car the way he wants it, right from chassis through the body, through the engine, through every other component that is required to be put, or assembly or sub-assembly. He plans it on a computer, and then moment he's planned it, it becomes a set, and the action based on the parameters and metrics defined by the user moves on the shop floor. So you have different types of bodies moving. At any point in time on every floor, there are about 100 odd assemblies going on. And unlike an assembly line, where a vehicle where everything happens around the vehicle, this is a mobile assembly line. A large number of robots moving in the space. You could see, if you were to come to the third quadrant down, how a car is being handled. Everything automated at the lower two. I mean, everything is automated and everything is very precise. Welding is precise. All mechanical operations are very precise. All driven by robots and numerically controlled systems. So this is the kind of industry we're looking at. Now imagine if COVID happened or any other VUCA event happened, this will go on regardless. The other advantage is that if you want to have a surge, you could create a surge. It's so easy. If you want to reduce your speed of production, you could do it. So everything is modular, everything is controllable. So this is where yet another opportunity lies in our TIH to look at creating, if I may say, a model IA to IA shop floor to create a very unique experience which industry could follow, largely the OEMs. However, so this is one more view of how all the assembled cars are getting together. I mean, almost, I'm told that in one day, almost today, as we speak, about 110 cars are being rolled out. That is the kind of capacity, but it has a huge surge capacity as well. But when we look at the real world, let me come to the challenges. So from this case study, I come to challenges. When we look at the real world, the challenges are huge. Whether it is defense, whether it is industry, whether it is condition-based monitoring, you have got legacy systems, systems which are still based on desktops, physical machines with costly hardware. And if you have to now create a geospatial experience, you need interfaces which are costly. You have to have multiple servers, virtual machines, they are licensing and a lot of issues. And I was the DG information systems. We were having a lot of problems in configuring multiple servers. It had become a very heavy baggage. And imagine if for every 800 troops, which is a battalion worth, you have to provide 2 to 3 vehicles just for the automation. Imagine the kind of footprint that you're carrying, despite creating virtual machines, because the humongous amount of data that goes in is difficult to manage. Then with legacy systems, you've got some radars which are old generation. You have to create interfaces. When you create interfaces, you find interoperability problems. You find data format and software problems. So therefore, when we look at geospatial technologies, it's a combination, like I said, of data engineers, of data technologists, of IT technologists, of data scientists, all of them put together who have to come up with workable solutions of hardware, software, data management to come up with a robust system. It is very, very difficult to scale and maintain legacy systems. There's a high compute time and high latency. To give you an example, in some cases, especially in the defense application, when the radar on the edge of the battlefield, when you pass the information to a central server, the information should come in 4 seconds, less than 4 seconds to be of value. It was taking anything from 7 to 8 seconds because of processing happening at various stages. Of course, when 5G comes, all this will get resolved, provided we are able to create a security infrastructure around it. And therefore, we have the other important thing, especially when it comes to defense application, is the cybertronics threat, the cyber and electronics threat, which is very, very important again. And therefore, when we look at this is some, should I say, big tickets that when one looks at legacy hybrid systems. And therefore, when we look at a way forward, we're looking at a minimum hardware system, a serverless system, a system on the cloud, and synergy of skills, a large number of subject matter experts who have to get together. So when we look at the TIH startups and programs, we have to look at a synergy of skills. We have to look at the current or the next gen systems, programmatically deployable, infrastructure as a code, which is where the future lies, software as a service, infrastructure as a service, neural networks. We have to work on neural networks and morphed neural networks you may have to create. Then we have to have granular control over workflows, especially when you look at IA to IA systems. Then you need a variety of runtimes. And the beauty of the infrastructure as a code is that you would use it, you would use the runtime only when there's a need. And therefore the system becomes, should I say, time and cost efficient. The compute times are low, latency is low, they are more maintainable, easily scalable. So this is the kind of system we have to generate. We have to work on very lightweight systems like mobile devices. I mean, I give you an example that for a battalion, we were having 2 to 3 vehicles to do automation. That's not how you could do automation. You have to have easy, lightweight devices like the mobile phones that we all hold today. I mean, imagine that when we were all the desktop variety and we were invoking our internet on the desktops, we had to move to either a cyber cafe or somewhere where we could go and invoke. And today you have a mobile device where you are available 24/7, 365. So that is the kind of system we have to look at. Of course, 5G, we have the software defined radios and software defined networks. That is where we have to maybe configure some of these software defined networks as a part of our GIS endeavors. And cyber security, with defense in depth thrown in, because every cyber security has some high security zones where you'll need defense in depth. That's very important. So in an overall analysis, therefore, when we look at geospatial applications, the whole world is defined by geospatial applications. Today, the challenge lies in putting geographers, data scientists, data engineers, data technologists, and IT professionals together to create a geospatial flavor and application experience. Thank you. If there are any questions, I would love to take them on.
Thank you, Prasad. Thanks for that detailed discussion about geospatial challenges and way forward, etc. Audience, any questions, participants? Any questions from participants? Roshan, do you have any questions?
What I say, this is Srinivas here, sir.
Yes.
Yeah, it is a wonderful exposure from the Indian defense sector and also the latest opportunities in 5G and worldwide opportunities by Dr. Anil Kapoor. What I would suggest is let us take all the inputs of specific to defense sector, since he is part of IIT, TIH, and as well as the professor with IIT Tirupati. So probably it is a good idea to interact with him for the participants, for more and more opportunities.
Thank you, Mr. Srinivas. For sure, I think there is a lot of future here, and I know it is the last presentation, and therefore, but it's very important to know where we are headed, because very important to curate these technologies. They exist somewhere in the world for sure, but I think we need to create some of these, should I say, technology demonstration models, which could then be replicated in industry pan-India and maybe globally. Thank you.
So probably like any other questions from students, participants?
Hello.
Yeah, Divyes, yeah, go ahead.
Yes, sir. Nice presentation. First of all, sir. I'm working on the armed forces for making a different technologies since last 2 years. And sir, I am facing the many problems regarding the meteorological data. So sir, I have seen in military and in air force, like they are struggle from the met data, real time met data you have mentioned. Okay, sir. So which are the visible options to get the real time data streamlining in RC2 application?
Right. You see, we have now there's a project which is being undertaken by CDAC at Pune, and the Indian Med Data department, Indian Med department is very much integrated with it. So when you look at any field area, uh, I mean, most of the data is available with the past data is available with the Med department for sure. And uh, say when you look at from ground zero to about 30 kilometers, if you want to know the wind conditions, the humidity, the temperature differentials, all this is available with the Met department. And when I was the DG Information System, we had started a program with the CDAC Pune to create a Met solution based on the past data. Say today we are at 3:30 on the 28th of June, and we pick up a geospatial point in Rajasthan, and we say, okay, last 10 years, what has been the Met data here, and therefore what will be the Met data in the next 1 hour? It was, I mean, that is the kind of analytics we were looking at. So you see, if you have to really get this data, one could be the Met department for sure. They have a lot of past data. Then we have the Space Application Center at Ahmedabad. They have a lot of Met data also. And maybe CDAC Pune would be a good place to engage with, to look at synergizing their effort with your effort to come up with a robust solution.
Okay, sir. Thank you very much, sir. Thank you, sir.
But at any stage you need any help, I'm there. I'll help you for sure.
Definitely, sure, sir. I'll be in contact with you, sir.
Yeah.
Okay. Any other questions? Yeah, probably I will just ask some general questions. So, since we are using this geospatial, the policy and all the government has implemented about 2021 onward. So I just want to know, like, where India stands in this geospatial technologies, especially on the defense sector, if we compare with US or China or Russia, etc. Where do we stand?
Yeah, it's a very good question. It's a very competing space, and let me put it this way: that you have to go sector wise. When we look at the agriculture sector, it's difficult for me to really be very specific to you because I've not done the kind of analysis to be giving you a very precise answer. But I'm aware that we have made a headway. I mean, there are a number of startups which have come around farming. I'm aware of some Israeli projects which are going on in Punjab. I'm aware of the ICRISAT project which is going on in Andhra and being scaled up. I'm also aware of a startup, like I said, in Tirupati, who's wanting to do this project. So when we look at the agriculture space, there is a huge amount of awareness which is getting generated. And when we look at the services sector, I think we have done very well. When we look at our e-governance model over the last decade or so, it has really scaled up. The way we've handled pandemic situation, it's much better. With time, it's only become better. I think we are coming with Aadhaar card and PAN cards and all the convergence happening around Aadhaar card. There's a huge future there as well. So I won't like to hazard a comparison, but I'd say that we are very much on road to do good in terms of using the geospatial technologies for services sector as well, and manufacturing. Like I told you, there is a huge amount of future. Most of the industry today is embracing industry 4.0. Of course, when I say most industry, I'm talking of the big industries, the OEMs. MSMEs are way behind. It'll take a lot of time for them to get there. But there is a huge amount of awareness today in the country. I'm aware of a lot of geospatial forums by E3 and others who have got together and taken it upon themselves. There's a lot of awareness in the states today, a lot of state administration. We have digital digital enabling officers who are some bureaucrats who've been assigned this task to bring in e-governance and bring in a lot of geospatial technologies. I've been attending a number of geospatial seminars where I've seen most of the states today have a lot of geospatial enablement, and a lot of NGOs, a lot of other organizations are coming up around geospatial. A lot of startups are coming around geospatial. So really speaking, rather than get into comparison, I think each country in the world is today moving ahead with a lot of geospatial, and so are we. And but the best is yet to come. Let me put it this way.
Okay. Okay, sir. Thank you. Any other questions from participants? Okay. If not, then let's thank the speaker. Thank you, sir. Thanks again for your wonderful talk. So we'll look forward to IIT Tirupati and have some
Thank
nice.
Thank you, Dr. Mariappan. It was a pleasure. It was a pleasure being with all of you. Thank you very much for a patient listening, and thank you for the questions.
So please take some 10 minutes, 15 minutes break. Then our CEO, Dr. Srinivas Pandam will talk about the geospatial technologies again. Okay, what are the, since he is the CEO, he will explain about our company also a little bit, and then he will say like what is the opportunities in India, industry. He is an industrial person, so he will talk about. So please stay with us for till 4:30, and then we'll continue. Thank you.
Hello. Hello. Yes.
Good evening to everyone. So this is almost a concluding session, and followed by that feedback and valedictory will be there. So with us, our CEO, Mr. Srinivas Pandamurthy, going to give a talk about geospatial industry opportunities in India. He received his business management from IMC and PG diploma in project management from University of Hyderabad. He's associated with many startup companies, and one of the main thing he is working is like he is working as an executive director person in more than 5 companies which are concentrating on IT, GIS, wellness, and healthcare organizations, etc. Also, he is non-executive director for JD Group, AAM Skies Geospatial. So that company is providing many has more than 600 plus employees with different divisions on that. And this is this Geospatial division, which is acquired by AAM Group from Australia. It's a 50-year-old company, which is also a market leader company in geospatial industry in Asia. So with this brief introduction, I request Mr. Srinivas to take over.
Thank you, Dr. Mariappan, and that's a very good introduction. And good afternoon to everyone. And I hope last 2 days of, yesterday's and today's sessions were quite useful for the audience, and also got the best of the information from the eminent speakers in various walks of life. I want to touch upon few points which are quite from the IIT Tirupati Vishkar I have Foundation. So where we are providing opportunities for multiple areas specific to skill development, human resources development, startup and entrepreneurship, collaborations, and creating various technology related, innovation related product development initiatives, support and all. So what we have done in the last, because I joined about 5.5 months or 6 months back into this organization, just to to create more startups, create more products which are indigenous in nature, and also bring some of the international collaborations from the Western world, because I live most of my time in the USA and Canada and Middle East. So with a lot of contacts, network and all, I thought it will be quite useful to bring all of them to a prestigious institution like IIT Tirupati, where we can collab and bring those kind of things. So that way, it has got unique advantages and benefits for the people who are coming, wants to start something on their own or in collaboration with with the small teams. So what we are planning to do here is a typical before even you start a company and organization and scale it up and make it successful and sell it for a price or expand it and and make it as a public listed or as a I know it has got based on the managemental ambitions, and it can go into any kind of directions, including mergers and acquisitions kind of thing. So with that kind of experience from last 26, 27 years in mergers, acquisitions, or selling the companies or buying the companies, I've been a serial entrepreneur in this area. So the first thing what we started looking at is let us collab with all the international organizations, domestic organizations, and bring them onto our ecosystem so that we identify, whenever there is an opportunity, comes from them, we are the first ones to know. Same time, whoever has got enthusiasm and energy wants to start something, we have enough resources on, on technology infrastructure as well as finance part and handholding and taking care of the various managemental support that is required to make them successful. It's not just creating an idea and taking it to the to the next level, or as per the norms TRL4 or whatever it is, but the real success of any startup is converting that into a real of financial success as well as market success, at the same time our social success, which has got a great potential. So with that, what we have done is we have tied up with a lot of industry associations in India, as well as outside, like whether it is the Confederation of Indian Industry, FICCI, there are NASCOMs, or FIEOs, or various other organizations that can bring various opportunities, market awareness, and also funding that is required. Then with the help of DST, we got hold of all the list of public sector undertakings, and almost close to 80 of them, which are very active. So we started writing to these people for checking out their problem statements, so that some of the problems and solutions can be used to create some of the ecosystem, startup ecosystem, or create very innovative products around that, so that the end of the day, whatever we develop or whatever we create, there should be an end user or a customer, whether it is a farmer or a defense major, or somebody, or an industry. So our idea is to connect with the industry first, so that we have a lot of ready-made problems that can we can bring onto the table, so that those problems can be pushed to all the people who are associated with us. So in that direction, we started moving. Then we also contacted all the line ministries and their departments. We have approached agriculture, research, educations to various Ministry of Ayush and healthcare sector, because PPT is position question technologies or geospatial technologies, are they can be used widely in multiple organizations in multiple ways. So everywhere there is an opportunity. So people whoever is working, I want you to, I mean, based on my past experience, I can say that focus on one area and stay focused on that, and do thorough market research around that, and create an excellent idea, or create a story, and around that, we need to add with certain numbers, which are financial numbers, how you are going to, that will come from market research and everything. And then it will become a comprehensive business plan. And then, you can bring that to us, and we are there to, to support you in any manner. So some people ask, like, so we are technocrats, and, we can solve any kind of problem that comes on our way. But how do we add on those things which are not, not our cup of tea? So that's where, what we are planning to do is, from Technology Innovation and Avishkar I have Foundation, we want to conduct multiple weekly programs, where we want to interact with the people who are enthusiastic and in one-on-one basis, so that we can bring one mentor from the industry or within our system, and who can help you to build all these things, like, that includes as a simple a presentation or a pitch deck or a one-page executive summary, or creating 10 slides that are required to go and impress somebody with your thing. And then we can scale it up to to next level of adding what you call the business plan around that, and or the operational plan around that, and create a clear path on a return on investments on whatever the time, effort, and energy that you're putting, versus how much you're getting out of it, and and how you need to take it to the next level, and how you can take the funds from our startup ecosystem, as well as, in case, I know there are certain restrictions, certain policy related guidelines. Sometimes they are also hindrance in terms of the acceleration of making things successful. So to avoid those things, what we have done is, we have already contacted several investment groups across India as well as outside India, particularly in the USA, like Wall Street investment groups too, many more to follow. So they are all now associated with us. So if any brilliant idea is there, we can also bring in those kind of investments, because somebody wants to create a product or a startup with a simple fund of 50 lakhs to 100 lakhs. Somebody might need 50 can be multiplied by 10x, and 100 can be multiplied by another 10x, things like that. So, but it has got its own value at the end of the tunnel. So to encourage those kind of people also, to evaluate them and seriously vet them, and to bring everybody, because every idea is unique, every startup is, every product built is quite different from one another. So, 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 so we want to personally evaluate each one of the enthusiastic startup entrepreneur or the product innovator and handhold him for some time until he becomes really comfortable from the market standpoint. So that is something which we would like to do, because that is what we were doing in earlier, like, as a company, if I need to give an example, Sky ITS, is the company which I founded in 2009, and by 2014 we became almost close to 1,000 employees. It is more focus on technology related product development using Microsoft as a platform. And the second is the geospatial and GIS related service sector based opportunities. And third is working with international opportunities. So when it became 1,000 people and we got a lot of projects more than 340 crores, so I decided to expand it to the international market. So then we got hold of AAM, that is Australian Aerial Mapping, which is a world leader in data acquisition with more than 30 aircrafts and multiple drones and a lot of LiDAR equipment. And we are the ones who did a lot of work in India also, be it Power Grid Corporation of India, coastline mappings, and to name it. So they came in, and then as Dr. Bharat told in the morning, so we want to be the small pie in a bigger cake. So we sold, I sold my company almost to 300 crores to AAM, and we became 20% equity holders in the company. So why I'm saying this thing to you is, so opportunity wise, there is sky is the limit, and if you start in a right way with a lot of enthusiasm and energy, you can do, and I can do, you all can do, and we all can do it together, and we are there to support you in whatever the format that is required. So I would like to congratulate all of you, and also would like to to utilize this the best opportunity, and take active participation, and feel free to write to us and work with us, and we are there to work with you, hand in glove. And if our capabilities and our skills, if they are not enough, then we have enough market reach in the market, whether it is in India or in other 40, 50 countries. We can bring the best of the brains who can help in multiple ways. So with that, I would like to thank everyone, and I hope you enjoyed this session, and let us meet again in the due course. Thank you so much.
Thank you, Srinivas. Yeah, so we are almost at the end of the session. So I'll just summarize the event quickly, and then we'll have some feedback if you want to share with us by unmuting your mic. So we have received about 160 participants totally, but out of which I think 8 people they have that repeat applications. So about 150 applications we have. So in this 150, about 60 participants have attended completely, and about 30 were attending regularly. Whoever is present here, almost all of them are very attentive, and then they have done that very well job, and they have listened to all the 8-9 lectures also. So yesterday we had a talk by Dr. Vaibhav Kumar. He was giving some urban challenges using GeoAI, and then from that we were able to see some of the challenging problems which can lead to some of the hackathon problem also. Then Dr. Isapatik, he given a nice introduction about geospatial data science, and then he explained about where he applied it in the lockdown period of the air pollution, etc. And Dr. Amya, he has given a LiDAR remote sensing opportunities and services. That itself can be taken as a completely new workshop that we are trying. Probably in the future, we'll arrange a separate workshop on the LiDAR remote sensing. So we will have, we'll invite you also for that. You can attend that. So we'll have a complete new workshop, training session which is related to the LiDAR remote sensing. Probably a 1-week workshop also we are planning. And then Professor Anand Patnaban, he was talking about cyber GIS especially. And cyber GIS, he was explaining very well about the Docker, containerization, Kubernetes, and all the modern technologies which can be helpful to solve some of the geospatial data science, where the data is vast and open data, and using that open data, how to generate the algorithm, how to use the algorithm, how to use the tools, etc. Explained very nicely. And yesterday again, Professor Sasi Shekhar, he explained about what is special about GeoAI and spatial data science. So he explained nicely about the different scenario where the spatial data science is used in, from simple things from the Uber, Ola, and what are all the different types of data available, what are all the markets available in the system. And today morning, Dr. Uttam Kumar from IIT Bangalore, he explained about machine learning, especially the problem which he explained about the part pool and how that can be captured, etc. And there are some open problems still there which can be tagged with using the geotag. Then Professor Bharat Yohani explained about the startup idea. He has already, he's the founder for the GeoNode, which is one of the famous company in this technology, geospatial technology. So he explained very nicely about what are the opportunities available in India, especially in this geospatial startups. Then later, Dr. Anil Kapoor, Dr. Anil Kapoor also explained about opportunities, innovation, and outcomes available in geospatial technology. So finally, our CEO also concluded about some of the opportunities which we have from our lab. So as I mentioned, like our CEO also mentioned, like we have plenty of opportunities here. So we can just get acquainted with this technology, and you can learn many more things. They will be conducting a series of workshops, etc., and training sessions also will be conducted. So you are all most welcome to attend the session. And apart from that, if you are a research scholar or if you are a student, we are providing some fellowships also, using which you can get some benefits out of it. Like we'll be providing some UG intensive, PG fellowship, and PhD fellowship, postdoctoral fellowship, all the things we are providing. So you can use that opportunity also, because you are attending this workshop. There may be some added benefits for you to consider that you have attended some of our workshops. So of course, other criteria we have based on that one we will take it. So with this, just conclude this session. So now it is time for the feedback. So if you have any feedback for this workshop which you would like to highlight, or if you have any negative points also, you can just inform us so that we can improve that in the future. So the floor is for the participants, so we can unmute and speak. Any feedback from participants? If you would like to speak something, you can unmute and speak. Okay, fine. So I think I have shared the feedback form also. So you can fill it if you want to anonymize that. That's not a problem. Okay. So you can fill that, and you can put the chat box also, like whatever the comments you would like to. So we will share the e-certificate through your email ID, which you have given while registration. And also yesterday's session is already available in the YouTube. We will share the same link with you. And today's lesson also will upload it in the YouTube, and then we will share that information also to you. Okay. So if any feedback is there, I'll just wait for a couple of minutes. Otherwise, we'll conclude the session and close the session. Okay. Roshan, would you like to add some words? Okay, fine then. So thank you all for participating in this workshop. So we'll contact you for other workshop series also. Then you can get benefit out of it. Okay. Thank you all. Thank you.
Thank you.